Hello, my name is Adarv and this is the first part of the basics of statistics in MATLAB. First, we will start off with basic functions that implement things from statistics in regression, plotting, and normal distributions. My code is in GitHub if you would like to see it. So here's a small script I made. The first part of it tries to find out whether there's a correlation between bean height and bean width. The second part tries to find out whether each distribution follows a normal distribution. Before I begin, I would suggest learning the basics of statistics before jumping into MATLAB, only because understanding it will be simpler if you understand the theory behind the code. So let me describe this script. So first I imported the data from my current folder, and if I run that, that includes my bean width and bean height. So next I took the data that included the bean width and bean height and separated them into a variable called data. Next, I picked out what the bean heights were from the data, which was the first column. And the same thing I did with width, which was the second column of the data. Next, I took the correlation coefficient of height and width. So all that says is if it's closer to 1 or -1, the two variables have more correlation between them, and height and width explain bean size. I will include the links to the descriptions to my description to understand what correlation coefficient means. But all you need to know for now is that if it's closer to -1 or 1, it's better than being closer to 0. So since our R is -0.7371, that means that the variables follow a negative pattern, and it explains the data pretty well, but not perfectly. So over here, it says our linear regression model is y equals 1 plus x1. And our R squared, which is how well our line of best fit explains our data, is 0.523. And this is my scatter plot, which has the data and the confidence bounds between them, which is a standard error of a regression line. So next is the hist fit. So what this does is create a density function for each histogram. So I made a histogram for each variable, width, height, and the dot product of width and height. And the density function of width is the first function, as you can see here. And I did a lillietest test for width, height, and the dot product of width and height. And if the lillietest test is 1, it basically says that the distribution is not normal. And if the lillietest test is 0, it says that the distribution is normal. How it finds that out is by using a confidence interval, which I will provide a link to in the description as well. The basic confidence interval is the 95th confidence interval, and if it falls within that range, it will fail to reject the null hypothesis that the distribution is normal. And it seems like the only distribution that is normal is the dot product of the width and height. Thank you for watching.